It movie, I can tell. All right, let's see what we have today. This is kind of a sigh of relief a little bit. Remember that thing we used in that right triangle to find that x over on the hypotenuse that starts with a p? The Pythagorean Theorem. We're actually going to officially study the Pythagorean Theorem a little bit. So you already know the Pythagorean Theorem. See, this is going to be a good day. Remember in a right triangle that the two sides that form the right angle are called legs. And the side across from the 90-degree angle is called the hypotenuse. So we have two legs and we have a hypotenuse. And you already know this Pythagorean theorem relationship. If I call one leg side A or length A and the other B and the hypotenuse length C, we know that A squared plus B squared is C squared. Did you ever wonder, well, where did that come from? I mean, that's fun to do, but where did it come from? Well, now you are smart enough to understand where it came from. Let's look at this picture. Triangle ABC is a right triangle. CD is an altitude drawn to the hypotenuse. Well, I bet that this divides the triangle into two triangles that are, can you finish that statement? Similar to what? Each other and the original triangle. So that's what we learned, part of what we learned in section 1. We're going to use that fact. I am going to start with leg A over here. A is a geometric mean. So I'm going to put it in the geometric means position. Between what? And they've given values. What is a geometric mean between that leg? Do you remember? Between what? Y and C. The whole hypotenuse, which is C, and the segment of the hypotenuse next to that leg. C and Y, Y and C. I'm going to write it C and Y just because that's the order the theorem states. Now we're going to look at leg B, the original leg. B is also a geometric mean, so it can go in the means position. What is B a geometric mean between? X and C, or C and X. Now I'm going to take the cross products on both of these. A times A is called A squared. C times Y is called CY. B times B is called B squared. C times X is called CX. Is it true that if you have an equation, you can add equal things to both sides of an equation and it's still true? Yes, called the addition property of equality. We can have the same thing to both sides. So I am going to take this equation and I am going to add equal things to both sides. I'm going to add the b squared on the left and I'm going to add the cx on the right. We're just adding equal things to both sides of an equation. Well, a squared plus b squared. A squared plus b squared. That's all I can write. Equals cy plus cx. I'm going to write the cx first if you're okay with that, just because alphabetically it looks so much prettier. Doesn't really matter. Now on the right side, let's see if we can remember some algebra. What can you factor out of the right side? What is common in C? A C is common. I can factor out a C. C is common. Leaving me what? X plus Y. X plus Y. Well, let's look at this little x plus y for a moment. X plus y. If you added x and y together, what would you get? C. X plus y is the same thing as C. Hey. What's C times C called? C squared. A squared plus B squared equals C squared, Pythagorean theorem. We know where it can come from those similar triangles and those proportions that we know these geometric means. Look at that. So now that we know the Pythagorean theorem and where it comes from, we're going to do some finding of x. Get your calculators running. X squared. Tell me the rest of the equation that I need to write for part A.
X squared equals 15 squared.
Equals x squared equals
6 squared plus 15.
There you go. Any order doesn't matter. 15 squares plus 6 squared. Now I'm going to get x by taking the square root of this, or more precisely, you are going to do that. Now we are not going to go to a decimal here. Tell me the number that's inside the radicand. 15 squared plus 6 squared. 2 what? 261? What happens if you take the square root of 261? You get this lovely decimal. So what do we do when we have these we have these radicals? Do you remember what we try to do to them?
Square numbers.
Find perfect squares. So what are those perfect squares? Maybe at the top of your paper you want to write a list of these numbers again. 4, what's the next one? 9,
09, 16,
16,
25,
25,
36.
36. How are you getting them?
64,
How are you getting them?
100. Oh, multiplying numbers by themselves.
There you go. You're squaring 2, 3, 4, 5, 6, 7. 121. I ran out of room, but it keeps on going. Can you find one? 9 goes into 261. How many times? 29 times? Square root of 9 times square root of 29. Now, just to make sure we found the biggest one, does any perfect square go into 29 from this list evenly? No, it doesn't. None of these go into 29 evenly. We found it. What's square root of 9? 3. 3 square roots of 29. There's our answer. So let's try part B over here. I'm going to write x squared again. Finish it up for me.
9 squared.
Or plus 9 squared equals 11 squared. Remember that the hypotenuse needs to be by itself, and we have to add the square of the legs. So on this one, I'd subtract my 9 squared. X squared equals 11 squared minus 9 squared, and x is going to equal the square root of this. And again, I want to know the number inside there.
40.
40? Square root of 40? So what's the biggest perfect square that goes into 40?
4.
4. 4 times square root of 4 times square root of 10. What's square root of 4? 2 square roots of 10. There's our answer. Down here, x squared. Finish it out for me. Equals 7 squared plus 17 squared. So I know x is going to be the square root of some number that you're going to help me out with.
338.
338? Probably doesn't go unevenly, does it? That'd be too easy. Perfect square, 338.
No.
Any luck yet?
Trying 36.
How much?
I tried 36.
You may be trying,
Too
oh, I don't know. Too low, too high. Did you find one? 169? Does 169 go in evenly? How many times? 2 times square root of 169 times square root of 2. What's the square root of 169?
13.
13 square roots of 2. So this cool list that I had right back here, we ran short. What's after 121? 12 squared is 144. 13 squared? 169. 14 squared? 196. Dot, dot, dot. Remember, it doesn't stop. One more. X squared. Finish it out for me.
9 squared. Oh, wait, my bad. 22 squared.
Yeah, plus.
Plus 22 squared. That's a leg. Plus 22 squared equals that 25 squared. So I'd have to subtract the 22 squared. So 25 squared minus 22 squared. What number do you get in the radicand? 141? Any perfect square? Has to be on the top row if it's going to exist. There isn't. There's the answer. Square root of 141. There isn't a perfect square that goes into this one evenly. So there's our answer. Pythagorean triples. We talked about Pythagorean triples.
Finally, yes. We have
A little bit. Pythagorean triples are simply integers that fit the Pythagorean theorem. And the smallest Pythagorean triple is 3, 4, 5. We can have Pythagorean triple families. In other words, if I take this 3, 4, 5 and multiply every number by 2, you get 6, 8, 10. That's another set of integers that fit the Pythagorean theorem. Or multiply it by 3, or multiply it by any number. That's why they say 3x, 4x, 5x. X can be any number, and you get another Pythagorean triple from the 3, 4, 5 family. So that's the most common one. 5, 12, 13 is the next Pythagorean triple. And again, you can multiply it by 2, multiply it by 3, multiply it by any number. You can put a 7 in all those spots, and you'd get another set of numbers that fit the Pythagorean theorem. And then 8, 15, 17, 7, 24, 25. I would remember at least these first two. They're pretty common. 3, 4, 5 is the most common that we run across, and it helps shorten up our work. So thank you for putting away the Rubik's Cube. Use a Pythagorean triple to find x and explain your reasoning. Think about it. Pythagorean triple.
8.
What is it?
8.
8?
Or no.
Do you know what he's talking about?
He doesn't.
Any other suggestions? 9? Is that right?
No, it's 3. 3. Not 3, but 9, yeah. He's right.
Well, which Pythagorean family is it? The family name is right there.
3, 4, 5.
Is it a 3, 4, 5? So if I take 4 times 3, 5 times 3, so the thing I'm missing is 3 times 3. There it is. It's 9. Our reason is the 3, 4, 5 family times 3. Let's try it down here. Well, maybe I'll leave your list right up there so you can compare the list. How about this one? You can tell me which family. It's the 5, 12, 13 family multiplied by what? 4. Correct. This is 5 times 4. This is 12 times 4. So 5, 12, 13, this must be 13 times 4, which is how much? 52. There's our answer. X must be 52. One more. Can you tell me the family?
7, 24.
7, 24, 25. This is 7 times 2. This is 25. That's the hypotenuse. 25 times 2. So this must be the 24 times 2. So X is 48. There you go. So those are just kind of shortcuts. You can figure them out with the Pythagorean theorem, but those are shortcuts if you remember the family. Damon is locked out of his house because he snuck out his bedroom window and he shouldn't have. Let that be a lesson to you. The only open window is on the second floor, which is 12 feet above the ground. Kind of dark, but there's 12 feet above the ground. He needs to borrow a ladder from his neighbor. If he must place the ladder 5 feet from the house to avoid some bushes, because his parents planted thorn bushes there. They were smart parents. What length of ladder does Damon need? Give me the answer real quick. What is it? How much? 13. How do we know so fast?
Because Pythagorean triple.
It's Pythagorean triple. It's the 5, 12, 13 family. 5, 12, 13, right over there. You can do the Pythagorean theorem, but that's where those Pythagorean triples are kind of handy if you can spot them. According to your company's safety regulations, the distance from the base of a ladder to a wall that it leans against should be at least 1/4 of the ladder's total length. You are given a 20-foot ladder. How far away do you have to put it? How much? 5 feet. 1/4. 1/4 of 20 is 5. You've got to put at least 5 feet away. Let's see. What's the maximum distance x up the wall? So how high up the wall can you actually go? Is this a Pythagorean triple before we do too much work?
No. No, it's not.
No. The only one with 5 on the side is the 5, 12, 13, and 20 is not a 13 multiple. So we will go with the Pythagorean theorem. X, I'm going to square it. Finish it up for me.
Equals 5.
Doesn't equal. Plus 5 squared
Oh, yes.
equals the 20 squared. There you go. So now we can go about finding the x. And notice these are decimals. So that means you can go ahead and go to decimals. Which one did you get?
19.
How much? 19.36.
36.
So 19.4 approximately?
Yep.
Gee, 19.4 feet up that wall. Converse of the Pythagorean theorem. Remember, a converse is where I take we have a hypothesis and a conclusion. I just reverse them. The conclusion and the hypothesis get switched. Originally, the Pythagorean theorem says if I have a what kind of triangle? Right triangle, then the sum of the square of the legs equals the square of the hypotenuse. Those are the words. A squared plus B squared equals C squared. So if I reverse it, if the sum of the square of the legs equals the square of the hypotenuse, I must have a right triangle. That's all it is, the converse, right over here. So that can tell us whether we have a right triangle. We also can use the Pythagorean theorem to tell us whether we have an acute triangle or an obtuse triangle. If I take the sum of the square of the shorter sides, and it is bigger than the square of the hypotenuse. If I take the sum of the square of the shorter sides, and they are longer than the square of the hypotenuse, it says this angle is an acute angle. Those things are too long. The C is not long enough to stretch clear across. It's going to be acute. If I add the squares of the two shorter ones, and it's less than the longer one, then I have an obtuse triangle. So we can tell whether we have a right triangle, an acute triangle, or an obtuse triangle by this test. So let's try it out down here. Determine whether these set of numbers measuring the sides of a triangle make an acute, right, or obtuse triangle. Now I guess first of all they say determine whether it actually makes a triangle. Do you remember how to test that? 3 numbers? If the two need to add up to be greater than the third, my two shortest, add 7 and 14. What do you get? You get 21, check, it's bigger than 16. So now we are going to test what kind of triangle it is. 7 squared plus 14 squared, we're going to compare it to 16 squared. 7 squared plus 14 squared, what do you get?
245.
245? And what is 16 squared?
256.
256. So if these are less, do you remember what it's obtuse. It is an obtuse triangle that we have. Right back over here, when I add them, if they're less, it's obtuse. Add them and it's greater, then it's acute. Or you can turn it around. I've kind of been saying it backwards how they wrote it. If the longest one squared is less than the other two, it's acute. The longest one squared is greater, it's obtuse. So let's check this one. Add 9 and 40. Does it make a triangle? Yeah, 49 is bigger than 41. We have a triangle. So let's try. Let me do it the order they say. 41 squared, we're going to compare it 9 squared plus 40 squared. What do you get for 41 squared? 1,680? 681? What happened on the other side?
1,640.
So what does that mean?
Right.
It's a right triangle. Fits the Pythagorean theorem. Must be a right triangle. So let's do some work from your book. Page. Somewhere. 551. Page 551, number 1. So write this down. Find x. X squared, what's the rest of the formula here? Plus 5 squared equals 13 squared. Or, isn't it what? That's a Pythagorean triple. 12. 5, 12, 13. We're done with that one. Number 2. You may use the Pythagorean triple, if it is.
We need to explain why.
They did not ask to explain why on that one. X squared, how would this one set up?
X squared
Equals 8 squared plus 12 squared. Is this a Pythagorean triple? I agree, no. So let's figure out that number you get in the radicand, that 8 squared plus 12 squared. $208.
Yep.
Need to find a perfect square. Big one, preferably. How much? 16? How many times does 16 go into it? 13. 13 times. So what's the square root of 16? 4. 4 squareds of 13. Number 3. X squared. How's it set up?
Plus 4 squared.
Plus 4 squared equals 16 squared. Is that a Pythagorean triple? Check it for just a minute.
No.
No, it's not. So we need to figure out the number we get in our radicatum again.
240.
240? Didn't hear any protests, so I'll assume that's right. Perfect square. How much? Okay. 16? How many times does 16 go in? 15 times. And again, we know we found the biggest one because no perfect square goes into 15. What's the square root of 16? 4. 4 square roots of 15. Number 4. Use a Pythagorean triple to find x. Explain our reasoning. Can you figure out which family? We have a 21 and a 35. Is it a 3, 4, 5? Multiplied by what? 7. 3 times 7 is 21. 5 times 7 is 35. So 4 times 7 is 28. There's our answer. And the explanation? It's the 3, 4, 5 by 7, I guess we can say for our explanation. Or multiply.
You say times?
Times 7. That works for me. Number 5. The mainsail of a boat is shown. What's the length of L to N? X squared. How would it set up? Equals 45 squared.
Plus 60 squared.
Is that a Pythagorean triple before we get too carried away?
Yeah.
What is it? How do you know? Yes. Is it a 3, 4, 5?
9.
3, 4, 5 times what?
No. Yeah, it's 5, 12, 13.
5, 12, 13 times
9.
times 9. 5 times 9 is...
Yeah.
12 times 9 is... Whoops, that didn't work
Yeah,
out.
right, yeah, sorry. Wait, no, that's 5.
I have a feeling it's a 3, 4, 5 times 15. What's 3 times 15? 45.
Oh,
4 times 15? 60. 5 times 15? How much? 75. Now, you could have gone through the Pythagorean Theorem. You would have found the right answer. Oh, it's a choice, isn't it? D. D is our answer. Multiple choice. 6. Determine whether each set of numbers can be the measures of the sides of the triangle, and then we're going to classify it. 15, 36, and 39.
They can.
Okay, so the first answer I'm actually going to write is yes. Add the two shortest, it's bigger than 39. So now we're going to classify it. I'm going to go ahead and start with the biggest one first. 39 squared, we're going to compare it with 15 squared plus 36 squared. So give me a number of either the left or right side and tell me which side.
1521 is the big side.
1521 is which, the left or the right? Left. The left is 1521? And is it 1521 on the other side? So it's a right triangle. Number 7. What do we have? 16, 18, 26. Does it make a triangle?
Yes.
Yeah, that's easy. Add the two smallest and it's bigger than the third. So I'm going to try 26 squared and the 16 squared plus 18 squared. Give me some numbers.
676 is 26 squared.
676. 580? So if the hypotenuse is bigger, the hypotenuse squared is bigger than the others, it makes it obtuse. Obtuse. That's probably easier to remember. When the obtuse is the bigger one when you put hypotenuse. Let's do 8.
Yes.
15, 20, and 24. Yes. They didn't even make it interesting. They didn't even give us one that doesn't make a triangle. It makes a triangle.
Would have been easier.
24 squared, we're going to compare with 15 squared and 20 squared. So numbers.
15 squared, 20 squared is 625.
625 on the right. How much? 576 on the left. So if the hypotenuse squared is less, it makes it
Acute.
acute. There's a banquet coming up. You might want to remember that. Oh, that's terrible. Your assignment. 1 through 32, page 551. And this edition of the geometry movie is over.